Okay, so this kind of looks like a mess, but I think this is the final breadboard version of what we need for the basic Vive controller. So what we have here is just the basic tracker here. Notice how it's currently charging off of 5 volts off of USB. And we have all the pogo pins connected to the breadboard. So the leftmost one is the ground, and the other 4 are the relative 4 buttons on the Vive controller. So those guys are all feeding into these generic buttons here, and they're connected also to the analog inputs on the Arduino. So right now, if we look at the screen for Arduino, they're just tracking the default. Oh, we gotta restart this Arduino. Actually, no, we won't be able to track it because the USB is not plugged in, but it should look like they're all set at around 3-ish volts. And then if you press the button, they get pulled down to ground, setting it to 0. So right now, if we press these buttons, these 4 LEDs change colors. And at the same time, in Unity, the 4 buttons toggle the 4 states. Okay, so now we have that set up. And then the problem that we had before was being able to both charge the tracker and then also be able to have it connected to a rechargeable battery. So everything to the right of here is what we had before, where we kind of used we reduced parts and we managed to get it to both charge and not have the charge be interrupted when any of the buttons are pressed down. So before, what would happen is if you pressed one of these buttons, it would turn to green, meaning that the charge would be disconnected because it got short-circuited and there's no more 5 volts running into the tracker. So right now we can both use the tracker and charge the tracker at the same time. Okay, so there's most likely a 3.7 battery already inside of the tracker here. So ideally, when we're attaching this to a controller, we want to be able to run the system with our awesome LEDs, and we also want to have it charge both the battery inside to keep the longevity of the system, and that would be optional as long as we plug in the USB cable here. Otherwise, we would just really need a really big battery to charge and power both whatever device we have here, the LEDs, and the tracker. Okay, so it's tracker foot. We don't need to see lights anymore. That's fine. So what do we have added here? So after doing the research for Arduinos in general, so we have this thing called a TP4056, which is pretty much a charger. And there's 2 types of these. So the first one, that's the TP4056 chip. And then there's these 2 chips here that prevent overcharge and over discharge. So the other ones that we have on the market don't have these 2 chips. Generally, the later ones all have these chips. And I think recently they also came out with a Type-C version over here and use smaller ICs, resistors and capacitors on here, but we're not going to go into that. Okay, so what's next? So what was the problem before? So first of all was that we needed to figure out a way to get 3.7 volts powering a 5-volt Arduino system, and also be able to charge the 3.7 volt battery inside the tracker. So what we added here was a 5-volt step-up IC. So from here, we can take the 3.7 from the battery. So assuming that this gets disconnected, then it runs into here and powers it, raises it up to 5 volts, and then powers everything on the right side here, which worked for a bit. But after doing some research online and YouTubing, figured out without certain setups, if you disconnected the USB, there wouldn't be enough current going into the 5-volt step up, and then the right side would power down or be in a low power state and would not run properly. So after talking and leaving messages on some YouTube videos, one of the guys just suggested adding diodes to the ins and outs, and then that way we can just steal the 5 volts from the input. So if the input becomes available, we're just feeding 5 volts into this 5-volt step up, so which is 5 volts to 5 volts, which is totally fine. If at any point we disconnect this, then these 2 don't connect to anything, So you have the ground here. So I'm just trying to film it. So yeah, so you have positive and the ground here. So those don't connect to anything. And then it automatically switches to the battery, which is being fed over here across this doohickey thing, 3.7 battery into the battery thing. And those come out the power outs here. And then the diodes kind of just limit the current so that we don't have, when we're plugged in, the 5 volts don't rush back into the battery and cause any issues. So this is pretty much the setup. So if we unplug the USB, boop, so you notice how it's not charging anymore. So the blue light indicates that it's charging, and then right now everything didn't disconnect, and it's drawing power from the 3.7 battery over here. Okay. So for looking into here at the bottom, you can see it's still charging. Okay, so it's kind of inefficient, but you know, we have one battery powering another battery, but it's also powering the system at the same time. So if we manage to bundle all this together, all we ever really need to do is plug in one USB cable, assuming that this is already plugged in, and it should be able to charge this battery and power everything at the same time. Although it might take a while, but you know, it is what it is. And if you want, you can disconnect the tracker and then charge it on its own and plug it back in, whichever one works. Okay, so I think that's about it. So when this battery is charging, this left light comes on, so it turns red, and so instead of the blue light, meaning it's fully charged. So we've only drained a little bit of battery, so we'll see if it actually goes back into charging state right now, but we'll see. Plug it back in. Right, so the red light's on now because we drained some battery and it's charging again. So I'm not gonna leave it forever, but if I just left it there for maybe a good 3 to 5 minutes, it should charge back up to full on this guy on the right, and then we have the blue light come on. So I think that's it. So I mean, we have an external battery that we made ourselves that can power the whole system. It can be charged with any USB input, and yeah, so these lights work, and then Unity works with the buttons. I guess the only thing that's kind of extra that we kind of should add is we need to be able to steal the data in, data out from this USB cable and also feed it into the Arduino. So that means if we plug in a USB, not only does it run this whole thing, we can also send data to and from the Arduino. So then that way we can also, you know, upload and update our code and also continue making more stuff for it. Yeah, so you can just see the blue light just kicked in, so the battery's fully charged again. So everything seems to be working. So yeah, hopefully we'll get somewhere else in the next video.